Hi. Did you know that there are 6 different conceptual modules we can use to multiply two whole numbers together? Today we are going to talk about 2 of them. My name is Camry Sievers, and today we're going to talk about multiplication of whole numbers. Today we are going to talk about the multiplication as repeated addition, which means when we add the same number again and again in order to find the answer to a multiplication problem. The second one we are going to talk about is the array model for multiplication. What is an array? An array is an arrangement of objects, pictures, or numbers in columns and rows. The first thing we are going to do is do a problem using the multiplication as repeated addition. How would we show our understanding of repeated addition to solve this problem? George has an after-school job at a local bike factory. At his job, he assembles 4 hubs and wheels. How many hubs and wheels does he assemble in 5 afternoons? Because there are 4 hubs and wheels, he assembles them in 5 afternoons. We would assemble this problem as 4 plus 4 plus 4 plus 4 plus 4 equals 20. The sum of 5 fours written as 5 times 4. So he assembles 20 hubs and wheels in 5 afternoons. A set diagram we could use to show this would be this. The 5 white circles stand for the 5 afternoons, and the small circles in the white circles stand for the hubs and wheels. The next problem we are going to do is using the array model for multiplication. Suppose Sally planted 5 rows of bean seeds and each row contained 8 seeds. How many seeds were in her rectangle plot? The 40 seeds that Sally planted from a 5 by 8 rectangular array, like the one shown, that can be seen in 2 different ways. So what data was used to make the conclusion that there are 40 beans in Sally's garden? In the array model shown, the number of rows and columns can identify the factors in multiplication. Also, the result of the product is found by counting the number of objects that are in the array. So if we count the number of beans in this array, there are 40 beans. We can see that there are 5 rows and columns, or 5 rows and 8 columns, or it can be seen as 8 rows and 5 columns, which means 8 times 5 equals 40, or 5 times 8 equals 40. How can we classify these different models on our own? This model is an array model. This model is also an array model. And the last model is multiplication as repeated addition. Each of these models we learned about today provide a useful conceptual and visual representation of the multiplication operation. I hope you guys had fun learning. Now Claudia is going to talk to you guys about the skip count method and the Cartesian product model of multiplication.
You're muted, Claudia.
Thanks, Camry. Have you ever looked at a multiplication problem and wondered how in the world you were to solve it? Or maybe you looked at it and you knew a way to solve it, but figured there was probably a more simple way. Well, today I'm going to teach you 2 models for solving multiplication problems. The first model is called the skip count model, and it is a very, very simple model. It's also very good for visual learners. So this model involves starting at a certain number and then skipping to the necessary number in the equation along a number line, like this one right over here. So, for example, you can think of it like counting by a certain number, counting by 5s, by 3s, by 10s, whatever. So for the problem 3 times 5, you would start at the number 0 and then skip to every third number 5 times. If done correctly, you would end at the number 15. Very easy to draw on a board and a great visual for students. The next model is called the Cartesian model, and this model is used to determine the number of possible outcomes using ordered pairs. So this is a great way to organize it over here. So the ordered pairs labeled A and B. A is to be a number from the set A and B to be a number from the set B. They would be organized in a table like this or in a multiplication tree, which Lexi will be talking about later. But these ordered pairs are organized, and then once they're all organized into separate ordered pairs, then those are called the Cartesian product, and that is the possible number of outcomes for all of these sets of numbers or digits, whatever they may be. Okay, so I hope you are enjoying this lesson on multiplication with whole numbers. Up next, we will have Lexi talking about different multiplication properties and a few more multiplication models.
I'm going to share my screen. Give me just 1 minute. Thank you, ladies, for reviewing those topics for us. 6 times 8 is 48, so don't forget to finish your plate. This is a cute little rhyme that could help you with some small multiplication problems, but they're not always going to be able to help you. So my name is Alexis, and I am going to review multiplication properties of whole numbers, and I'm going to review 2 visual models that you could use with multiplication. One is the rectangular model of multiplication, and the other is the multiplication tree model. There are 6 multiplication properties that are actually listed in our textbook. One is closure property, and the definition of it is if A and B are any 2 whole numbers, then A times B is a unique whole number. Number 2 is commutative property. If A and B are 2 whole numbers, then A times B equals B times A, which actually just means that the order doesn't matter of your multiplication problem, that you will always end up with the same product. Number 3, associative property. If A, B, and C are any 3 whole numbers, then A times the quantity of B times C is the same as A times B, or the quantity of A times B times C. Number 4, multiplication identity of 1. The number 1 is a pretty unique whole number, so anything multiplied by 1 is actually itself, except 0. Number 5, multiplication by 0 property. For all numbers, anything multiplied by 0 will equal 0. Multiplication over addition. This is actually just distributive property. That's what we usually hear it called. So A times the quantity of B plus C equals A times B plus A times C. Multiplication properties are the foundation of multiplication. So it's good for us to understand these so we can understand the problems that we're trying to solve. These are some images of multiplication properties. This is the closure property here. This is multiplication identity of 1. So here it shows you 1 times 1 will equal 1, 1 times 2 will equal 2, and so on. This is associative property. Here's distributive property. It shows you that the outside number is multiplying by everything on the inside. Here's the 0 property, showing you that everything times 0 will equal 0. And here's the commutative property, explaining that it doesn't matter the order that it will be in. A real-life commutative property is during a physical exam, Sarah's doctor checks her blood pressures, blood sugar level, and her heart rate. The situation is commutative. The doctor could check Mary in any of the following orders. And here are the orders listed below. He could do them anyway, and the numbers are always going to end up the same. The first model of multiplication that I want to review with you today is the rectangular model of multiplication. In 4th and 5th grades, students are introduced to the multiplication of multi-digit numbers. One of the more effective means of finding these products involves a rectangular model, which connects to the 3rd grade result that the area of a rectangle is the product of its width and length. For example, you can find the product of 23 times 37 by finding the area of a rectangle with a width of 23 and a length of 37. This would be better for like a visual learner who needs to see what they're supposed to be multiplying. If they understand area, then they're going to understand this a lot more easier. The second model that I want to review is the multiplication tree model. Claudia actually mentioned something about that earlier with the Cartesian method. In the same way, a factor tree shows the numbers that come together to create a larger number, and it branches out as it progresses because each resulting factor then gives way to its own factors. In other words, a factor tree is a tool that breaks down any number into its prime factors. Here, it shows 150 being broken down by a multiplication tree model. So 150 is broken down to 10 and 15, and then 10 will be broken down to 5 and 2, and 15 will be broken down to 3 and 5. Here's the multiplication tree model that would kind of go with real life. Timmy has 3 tops, blue, red, and green, and 2 shorts, jeans and khakis, that can be mixed and matched. How many outfits does he have? And right here they have the diagram of the tree model showing what all the outcomes could be. These properties simplify mathematics a great deal for students and yourself. Our students really do depend on this, and so do our careers. We need to know this information well. We as a group hope you found great benefits learning about multiplication models and multiplication properties. We hope you see how beneficial it will be to you in the classroom and in real life situations that they may apply to. Thank you.